Okay, so we're going to simplify square roots of negative numbers here. Let's start off with, if you go back to my previous video, what we watched there were simplifying powers of I, okay, which were your I to the 100th power or I to the 7th power. I raised the powers higher than 2. Okay, so let's say we have the square root. Let's say we have the square root of negative 25. What is this equal to? Well, if we're looking at the square root of negative 25, what this here says is that we need a number that when multiplied by itself, it will give me 25, right? That's what this here says. It give me, negative 25. That's what this here says. But right now, it doesn't look like any two numbers, because if we take 25, we can't do 5 times 5 because that gives me a positive 25. And we can't take negative 5 times a negative 5 because that gives me a positive 25. So we can't take any of these, so what do we do? Well, if we're looking at this here, we also, now the reason that we don't take negative 5 times positive 5 is because that's not the same number, okay? One is on this side of the number line and the other one is on this side of the number line. So they're not the same number, so we cannot take that. All right. Well, this introduces us to the topic called imaginary numbers. Okay, so let's take a look at some. One second here. All right, so let's take a look at this example here. Like we said, the square root of negative 25, right? Okay, this would be equal to the absolute value of negative 25, which is 25, multiplied times the square root of negative 1. Because if we multiply negative 1 times 25, we get a negative 25 up in the radical, correct? Now, from our rules that we talked about before, what did we say that the square root of negative 1 was? The square root of negative 1 is equal to I, right? Just like I squared is equal to negative 1. So these are the rules that you need to remember. So if we have the square root of 25, which is equal to what? 5. Perfect. Times the square root of negative 1, we said is I. 5 times I. This is equal to 5I. So the only thing that's different from the square root of 25 and the square root of negative 25 is that we've introduced this new number called an imaginary number I into when we're dealing with negative square roots, square roots of negative numbers. Okay, let's take a look at another one here. We have the square root of a negative 100. Right? Well, if we look at negative 100, what we do is we take the positive square root, multiply it times negative 1, because this will be a negative 100 when we multiply them, is equal to, well, 100, the square root of 100 is 10, times negative 1, the square root of negative 1 is I, so that's times I, which will be 10I. So if you're recognizing this pattern here, well, let me do another one, and I want you to tell me if you can recognize the pattern that we see happening here. The square root of negative 49 is equal to the square root of 49 times the square root of negative 1, which is equal to 7 times I, which is equal to 7I. If you recognize the pattern here between these numbers, what I want you to see is that the only thing that's different from their absolute value, them being positive, the radicand being positive, this is the radicand here, from the radicand being positive to it being negative, is that you have this imaginary term I. That's the only thing that's different, okay? So I don't want you to forget that. So let's do one more example, then we're going to cut this video here. Alrighty, let's do this example here. Let's get all this out of here. All right, so let's take a look at something a little bit more complicated here. Not that much, just a little bit. So we have 3 times the square root of negative 16. Okay, well, first of all, what do? we take 3. We're just going to bring 3 straight down like it's nothing. Times the square root of negative 16. Well, if we don't see this 3 here, we know how to deal with this, the square root of negative 16, like we did in the previous problem. We multiply it times the positive square root times negative 1, because this will give me a negative 16. So it's 3 times the square root of 16 times negative 1, the square root of negative 1. So we know 3 times the square root of 16 is 4, so 3 times 4 times the square root of negative 1 is I. Well, what's 3 times 4? What did 3 times 4 say? 3 times 4 is 12, multiplied times this I, which will give me 12I. Okay? Now, just so you can understand this, let's go ahead and do one more example, and then we're going to actually cut this video. So, let's see. If we have, let's say we have 2 times the square root of negative 49, right? We bring this 2 straight down, times the square root, we take the positive square root, right, times negative 1. 2 times 49 is, the square root of 49 is 7. So 2 times 7 times the square root of negative 1, we said here is I, so I. So 2 times 7 is what? 2 times 7 is 14, and we multiply it times the I, so 14I. Okay, and this is known as simplifying square roots. Simplifying square roots of negative numbers. Or like we said, this number here is known as your radicand. I want you to remember that that terminology, the radicand. Now let's just do a quick point here, kind of not off topic, but just something that you need to know. We take the square root. Now it assumes, if it's a square root, it's assumed that it's a 2 here, actually. Okay, so this is the radicand. This 2 here, this number here that tells you to what root you're taking it, in this case is 2, is called your index. Your index, okay? And we'll see these problems a lot more when we get into rational exponents in a couple of videos later, okay? Thanks.